So in kinematics, especially in motion in one dimension, there are these two terms which are not the major topics, but are important in some of the numerical problems. We need to have understanding of both of these concepts. Stopping distance is related with vehicles, so at a particular speed, um, how much distance we have to maintain with a vehicle which is ahead us, so that is stopping distance. So to understand stopping distance, one thing for sure that maximum retardation of maximum retardation uh, that can be offered by the brakes, uh, let us suppose it is minus a. As per definition, negative acceleration is retardation. Okay, then there is final velocity 0 which we want, and if u equal to u, some velocity what which is there, then stopping potential, I'm indicating it with capital D, whatever be the symbol you can use to just make it uh, so that you can understand that this is stopping this distance and not an ordinary distance. Then okay, so we are going to apply v square equal to u square plus 2as. So v square is 0 because ultimately it will stop. U, the velocity by which it is moving, 2ad. So from here d is equal to u square by 2a. Acceleration is constant, so we can say that stopping distance is directly proportional to square of the speed. So if you increase your speed by small amount, you need to be conscious that now your stopping distance should be greater. Let us suppose, uh, just compare this using an example, um, that if stopping distance for a vehicle at a speed 20 kilometer per hour is 10 meter, then find stopping distance for a speed 40 kilometer per hour. So in order to solve such type of problem, what we can do, we can say d1 by d2 is equal to u1 square by u2 square, because it is directly proportional to u square. So whatever with the constant term which is um, 1 upon 2a will be eliminated. So here first distance is given 10 meter, second we need to find u1 is 20 kilometer per hour. I'm not changing it into meter per second because we are uh, taking its ratio. So 40 kilometer per hour, so units will get cancelled, so no problem with that. So here it will be 20 multiplied by 20 divided by 40 multiplied by 40. So it is 1 by 2, 1 by 2. That will go there, that will go there. So d2 will be 40 meter. So you can see if you double the speed, you have to be very conscious that now distance, the safer distance, the gap between you and vehicle ahead you should be increased 4 times, and if you triple the speed it will be 9 times. So that is why there is always there is a safer distance for particular speed. Okay. Next is stopping distance. See, whenever we are okay, next is reaction time. So whenever suddenly something happens, we have to react on it. So if we consider the same situation for vehicles, so if I see something in front of me and I have to apply brake suddenly, or if a vehicle ahead of me suddenly stops, so I also have to press the brake. So in between my I mean whatever I have seen and how I have reacted, so in between these two events there is a time interval which is reaction time. So if so here what we will do, we'll find reaction time error actually. So if uh, speed of vehicle is u, then distance traveled during reaction time is uts, which should be keep in our mind. So if we go back to this stopping distance, here we have to take care that not only stopping distance we have to keep in our mind, but reaction time error should also be there in our mind. So I'm combining both the concepts in a single question. Okay, so maximum retardation uh, offered by a vehicle is mm, if maximum retardation offered by a vehicle is 5 meter per second square, which is pretty low. Actually, it is more than that. Anyway, the vehicle is moving, actually running, whatever, with velocity 20 meter per second. And the reaction time for because it varies for person to person. The driver is 0.2 second, then find the safer distance between the vehicle and another vehicle ahead it. Okay, so here what we have to do, uh, we have to find stopping distance, which directly we know is u square by 2a. A is minus r, as r is minus a, so here it is. Sorry, actually it is totally calculated one, because we have, while we have derived the formula, we have taken care of that negative, so we are going to directly put this value, 5 meter per second square. I was deriving it, but now we can directly put it here, because we have taken care of that negative and all that already. So this s, which is stopping distance, um, stopping distance, yeah, I should write it d, I'm writing it s, in fact s1 I'm writing it. So u square is 20 square divided by 2 multiplied by 5, so it is 400 divided by 10, that is 40 meter. But there is a reaction time error also. So distance traveled, this is stopping distance, and distance traveled during reaction time. So that is S2, which is equal to UT reaction time. U was 20 multiplied by 0.2, that is 4 meter. So safer separation will be S1 plus S2, that is 40 plus 4, that is 44 meter. So while driving, keep this thing in your mind. If your reaction time is more, you have to keep more distance than prescribed. That's all.